Okay, so today we're going to talk about solving rational equations, and to do that we have to get a common denominator. And to get a common denominator, first you got to see, is there any denominator you have to factor? If you don't have to factor any, then can go on to the next step. Okay, and the next step would be to take the first denominator and write it down. So our first denominator is x plus 3. Then you would look at the next denominator and see if it's different. If it is different, then you need to write that down as well. And in this case it is, so we're going to write x minus 3. And that would be our common denominator right there. So what we're going to do with that is we're going to multiply that to both numerators of our equation. Okay, what happens is when we solve this, we're trying to cancel the denominator. So in this case, we'll cancel the x plus 3's, and we're left with 6 times x minus 3 equals, and on this side, it would be x minus 3's that cancel, and we're left with 4 times x plus 3. We're going to distribute. 6 times x is 6x minus 18 equals 4x plus 12. And now we're just solving a regular equation. So we get 2x equals 30. So x would equal 15. Okay, so on the next two examples, we're just going to find that denominator, that common denominator. So again, first thing we got to do, factor anything that we can factor. So here we can factor x squared minus 4. Okay, and because it's square root, we can just take the square root of both of them and get x and 2. But because it's minus, one has to be minus, one has to be plus. Okay, and then this one we actually have to factor as well because we cannot have that negative x. So to do that, we're going to take out a negative 1. So again, the common denominator, we write down the first one, which is x minus 2. Then we look at the second one, which again is over here, x minus 2x plus 2. Is there anything different in there? And there is. It's this x plus 2, so we need to add that to it. And in the last one, we have this, for this down here. And what's different is that negative 1 right there, so we need to put that in the front. So that would be the common denominator of this rational expression. Okay, we're going to do another one. Okay, we're going to factor each one. So the first one we're going to do is this 2y squared here plus 3y minus 2. Okay, we're going to do the x method. Remember, it's a times c, so 2 times 2, which is 2 times negative 2, which is negative 4, and 3. So we got 4 and negative 1. Remember, we put them both over the a, which is 2, and the letter, which is y. Reduce if we can, so that reduces the y over 2. So this will be y plus 2, y, 2y minus 1. Okay. This one here, this 2y, we can't do anything with, but we can do something with that y squared plus 2y. We can factor that. The GCF of that would be y, so we're going to factor out a y. All right. So again, to write our common denominator, we take the first one, which remember now is this, and we write it down. So y plus 2 times 2y minus 1. Then we go to the second one. Is there anything different? And there is. We have to add a 2y to it. And then the third one, there is nothing different here because this y is covered by that 2y, and we already have a y plus 2. So here would be your final common denominator. All right, so this one we're actually going to solve. Yeah, we're actually going to solve this one. Okay, we can't factor the first one. We can't factor the second one. Okay, so we can't factor the first one, can't factor the second one, but we can factor this one, x squared minus 1. And we can do the square root, and we're going to get x plus 1, x minus 1. Okay, so again, we write the first one. So our common denominator, to get our common denominator, which is x minus 1. So our common denominator, so we have x minus 1. The second one, which is x plus 1. And then is there anything different in the third one? No, we have both of those. Okay, so now to solve this, we're going to multiply each one of these numerators by that common denominator. So we're going to have x minus 1, x plus 1, times 1 over that x minus 1 plus, and we're going to do it again, x minus 1 times x plus 1 times the original 1 that's there over x plus 1 equals, and then again one last time, x plus 1, x minus 1 times that 2 all over that denominator, which is x plus 1, x minus 1. Okay, then we cancel things out. So what's the same in both the top and bottom of this one? It's x minus 1, so those cross out. So we're just left with x plus 1, x plus 1, plus second one, x plus 1 is the same, so we're left with the quantity x minus 1 equals, and then in this one, they are both canceling out, leaving us with just 2. Okay, so we're going to combine like terms. So the x combines with the other x to give me 2x. These ones end up canceling out, so we get 2x equals 2, so x equals 1. Okay. It says, is the solution a solution to the original equation? The answer to this would be no. The reason why, if we substitute one for x, we will get a denominator that is 0. That is considered an extraneous solution. So if we put our answer back in, we can get an extraneous solution if we get a denominator that is 0. All right, so let's do some practice problems. In this case, they're both 2x, so that's the common denominator. So we're going to multiply both the top and the bottom by 2x. So what will happen is that 2x will cancel with that, giving me with x squared minus 14 equals, on this side, that 2x will cancel there, leaving me with just negative 5x. And now it's a quadratic we're going to solve. We're going to move the 5x to the other side. So we have x squared plus 5x minus 14 equals 0. We're going to solve by fraction, so we're going to do x method. So negative 14 on top, 5 on bottom. Okay, so we're going to do 7 and negative 2. So our factors would be x plus 7 and x minus 2 equals 0. So our two answers would be x equals negative 7 and x equals negative 2. Oop, that should be a minus 2. So x equals positive 2 there. We just have to double check that to see if they are extraneous solutions. Okay, to do that, just take those answers and look at the denominator. 2 times -7 is -14. That's not 0, so that's fine. And then 2 times 2 is 4. That is, again, not 0, so that is fine as well. Okay, now we're going to do the next one. And the first one we have to factor, so we're going to do X method for it. So it's 12 and -7, which will be -4 and -3. So this will now be X minus 4 and X minus 3. Okay, which happens to be my common denominator, so I'm going to multiply that to each top, each numerator. So X minus 3, X minus 4 multiplied to each thing. Okay, so we're going to look here. X minus 3 cancels, X plus 4 cancels, so I'm just left with X squared minus 20 equals, on this one, X minus 3 cancels, so it's 3 times X minus 4. On this one, X minus 4 cancels, so it's 5 times X minus 3. Okay, we're going to distribute. Gives me 3X minus 12 plus 5X minus 15. Okay, bring down my X squared minus 20. We're going to combine X's and the whole numbers here. So X squared minus 20 equals 8X minus 27. Now we got to move everything to the other side. So it's X squared minus 8X plus 7 equals 0. Again, we're going to solve doing X method. So it's 7 on top, -8 on bottom. So that would be -1 and -7. So our factored form would be X minus 1 and X minus 7 equals 0. So our two X's would be X equals 1 and X equals 7. We just have to check to make sure they're not extraneous solutions. And they're not. The extraneous solutions would be 3 and 4 because that's what would make the denominator 0. So we are good. So those are our final answers. Okay, we're gonna do these last two. We're not gonna do the ones on the last slide, just these last two. So we're gonna find the solution to these. Okay. Again, to find our common denominator is the first one and the second one. So it's 4x here. So 4x. We gotta multiply that to all three of these. Okay. So the 4 cancels out here. That gives me x squared. The x cancels out here. That gives me -20 equals 8x. Move that 8x to the other side. Okay, X method, so it's -20 and -8, which would give me -10 and 2. So it's X minus 10 and X plus 2 equals 0. So our solution would be X equals 10 and X equals -2. Double check to make sure we have any extraneous solutions, and since it's just X, none of those would be 0, so that'd be fine. And then our last one, we had to factor the first problem. It's A times C, so it would be -6 on top, -1 on bottom, so that would be -3 and 2. But remember, we have to put these over A, which is 3x and 3x. So this one cancels to x over -1. So this changes to x minus 1 3x plus 2, which is my common denominator. So that's what I'm going to multiply to each top here. Okay. So all of these cancel out. So I'm left with 4x squared minus 24x. 3x plus 2 cancels here, so it's plus 3 times that x minus 1 equals, the x minus 1 cancels out there, so it's negative 4 times 3x plus 2. Okay, so we're going to distribute and distribute. So we have 4x squared minus 24x plus 3x minus 3 equals negative 12x minus 8. So we're going to combine the middle there. So it's going to be 4x squared minus 21x minus 3 equals negative 12x minus 8. Now we're going to move everything to the other side. So we get 4x squared. That would be minus 9x plus 5 equals 0. So we're going to do x method. A times c would give me 20 over negative 9. And that would be negative 5 and negative 4. Okay, we're going to put them 4x over both of them, which would change this to x over negative 1. So our two factors would be 4x minus 5 and x minus 1 equals 0. So our two would be x equals 5 over 4 and x equals 1. But we have a problem, because if you go up to the top, if I put 1 here where it says x minus 1, I'm going to get 0 as the denominator, so that doesn't work. So there is my solution.